Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in this series developing the brain plugin for machine learning in Grasshopper. So what I would like to teach you in this video is a technique that uses inheritance in C# in order to make the development of our plugin more streamlined, elegant, and especially using less redundant code. Because if you remember, when we were developing in the previous video, when we were developing a component for asynchronous post request, we had to do this whole thing of adding properties, creating a function that does the asynchronous post request, and then handling how that works in the cycle of Grasshopper. But if we're going to be developing a lot of components that use asynchronous post request, which is what we're going to be doing, then that would involve a lot of copy pasting large chunks of code across the same chunk of code across components. So in order to avoid that redundancy and the possibility of failing, etc., what we're going to do is we're going to basically create a superclass of Grasshopper component, a template that is going to incorporate all of that functionality. And then whenever we want to implement an actual component that uses this asynchronous post request functionality, instead of inheriting from the Grasshopper component plain template, we're going to inherit from the template that we're going to develop ourselves. And that's going to be a template that we're going to develop using inheritance, where we're going to take the base class and we're going to add custom functionality so that we can reuse this functionality over and over again in many different instances of our custom components. Okay, I'm going to show you what this means, why we do that inheritance, and examples of how to implement that in our plugin. Let's take a deeper look at all of this mess here. Before we start writing any code, I would like to do like we typically do, which is take a little bit of time and distance to think about what we're doing conceptually and plan perhaps what we're about to do, right? So if you remember, I said in the introduction that what we're going to do is we're basically going to create a template of reusable code that we can use for all the components that are going to be doing post request to online API services. And if, as you have seen in the previous videos, creating a post request synchronously, specifically in that method that was expiring solutions, etc., it requires quite a lot of code. So what I would like to do is, because we know that we're going to be implementing a lot of components that use the exact same post methods and post functionality and asynchronous double update, whatever, what I would like to do is, instead of having to copy paste a lot of code and maintaining all that code for, I don't know, 15 different components, what I would like to do is I would like to create one template that we can use that incorporates all that functionality, the posting, the delayed expirations, etc., so that I can create components that use that template instead of the standard template that comes with Grasshopper components. Because if you remember, whenever we create a Grasshopper component in Visual Studio, we do something like this. We go here, we say add new item, and then we choose empty Grasshopper components, my component, whatever. And what you can see is that this component is inheriting from Grasshopper component, which is an abstract class. And an abstract class means that it's a class that contains a lot of methods and a lot of functionality, but that needs to be inherited in order to be used, right? And the idea is that Grasshopper component already incorporates like all this functionality and everything that you need in order to have a component show up on the Grasshopper canvas and be used by the Grasshopper engine. The way that works is that in coding terms, in C# terms, the Grasshopper component is an abstract class. An abstract class is one that already incorporates a lot of functionality. It has stuff that you can use already. These are typically called the regular methods or the virtual methods or the properties, etc. I'm highlighting them here in blue. But it also has abstract methods. And abstract methods are those that the class is telling you, as a Grasshopper component class, I'm asking you to implement your particular version of these functions. And that's why when we start these classes, we know that we have to implement register inputs, output parameters, solve instance, because it's mandatory from the Grasshopper component template. So this is the stuff that we need to implement. And out of that, we can just create all the different Grasshopper components that we want by just inheriting from that class, I'm not pronouncing this well, inheriting from that class and making sure that in each one of the components that we implement, we make sure that we add our custom implementations for all these abstract properties. Okay? So this is the regular way. However, if we know that we have some functionality that we're going to be using over and over again, instead of implementing that in every single component that we create over and over again, copying and pasting, that's not healthy and it's not maintainable, it's not good practice. So the better practice would be to say, well, you know what? From the general abstract class Grasshopper component, what I'm going to do is I'm going to create a subclass that inherits from everything in the parent, so in Grasshopper component, but in my abstract class, which is specific for some kind of use that I want to do. For example, in our case, we're probably going to call this Grasshopper component post, because what we're going to do is we can say, we're going to create an abstract class that inherits from a parent. And in that abstract class, we're going to we're going to add additional custom functionality that is going to be shared by all components. So in this case, for example, in our case, it will probably be something of the kind having a post request, doing all the cycle of expiration, etc., etc. And then from our abstract class, we can still also ask whoever implements this that you still are required to implement the abstract methods that are coming from the parent. We can do that as well, all right? And then once we do that, what we can do is we can abstract and we can inherit and create custom versions of this enhanced template that we are creating that already incorporates, for example, all the post functions, expiration, etc., etc. And at the same time, because we're not really modifying the original, we can also still create versions of the original Grasshopper component without the additional functionality. We have now two templates. It's just that the new template, in a way, it's using the base template as the base itself. Okay? This may have been a little too abstract, but this in a nutshell is one of the ways you can use inheritance and polymorphism in C# when implementing more complex projects where you know that you're going to be reusing a lot of code between certain parts of your project, okay? So what I'm going to do now is I'm going to show you an example of how can we create a template for post requests that we can reuse for any component that we want to create that uses synchronous post request. And then after that, we will do the same for asynchronous post requests. And very likely we will do that also for GET requests, so that for the sake of completeness, we have templates for all the possible cases that we want to address with our plugin. Let's take a look at how that looks like code-wise. If you remember back the project, so we had a folder here with the components that we had already prototyped, and I created a new folder here called templates where I'm going to drop things that are not exactly Grasshopper components, but that are useful to the other Grasshopper components that I'm going to be developing. So what are we going to do? The first thing I would like to do is I would like to implement a template for synchronous post requests. So if you remember, the prototype that we did here at post request component was basically a component that was very normal. It took all the inputs, and then here it has all this bunch of code, which is what does the post request. This is what I would like to avoid copy pasting across multiple instances. So what we did in the asynchronous version is that we actually created a function called asynchronous post with a bunch of inputs that returns an asynchronous task, right? So I would like to do something similar. So I would like to create a template that incorporates a post function, and that incorporates this function in a way that is reusable by all the children components. So let's see how we would do that. The first thing that I need to do is I need to create a class that inherits from the Grasshopper component. So what I'm going to do, I'm going to go to templates, I'm going to add a new item, but I'm not going to add an empty Grasshopper component. What I'm going to add is a simple class, and I'm going to call this Grasshopper component, right? And then underscore post synchronous, all right? And this is going to be just a simple class. I'm going to dock it here on the side so that we can see things side by side, right? And then what I'm going to do is, first of all, this has to inherit, as per our diagram, from the Grasshopper component class. The way I do that is by coming here and saying, and using the colon, and then saying this class must inherit from Grasshopper underscore component. Okay? Beautiful. The next thing, I'm going to make this public, and I'm going to make it abstract, just to make sure that no one can actually create a Grasshopper post sync like this. What they have to do is we have to inherit from this class. And then the next thing that I would like to do is I would like to create whatever is necessary as additional functionality. So in my case, what I want to do is I want to create some kind of function similar to this one, where that I can use to do synchronous post requests. So what I'm going to do is I'm going to go full screen here so that you can see better. And I'm going to copy and paste the asynchronous post from the previous request. However, what I'm going to do is I'm going to rename this, and I'm going to say this is now post. And then this, instead of void, is going to return a string, which is going to be the return of this request. I'm going to remove all the task stuff because we don't need that anymore, because this is not going to be asynchronous. And I'm going to remove anything that was part of this esoteric expire solution kind of method that we were using. So for example, I'm going to remove here, I'm going to create, this is going to be a variable called response. I'm going to not deal with current states, not should expire, not the threads or whatever, but instead, if the response is correct, I'm just going to return this response. All right? And if something goes wrong, instead of doing all of this, what I'm going to do is I'm going to offer some kind of error like we did here. So for example, something went wrong with the request. So I'm going to remove all of this, and I'm going to return here an empty string if something goes wrong. All right? Beautiful. So now I have a protected method. Protected means that it can only be used by children of this class. And then another thing that will be very useful is to create a constructor. And to create a constructor, because if you remember, when we use Grasshopper components, there's always a constructor that takes some information and passes it over to the parent class. So what I would like to do here is I would like to say, you know what? Let me go to Grasshopper component. Let me find the constructor. Actually, I'm not going to do it this way. Sorry. So let me go here and say, I'm going to copy this. Where am I? I'm going to copy the constructor, and I'm going to say, whoever creates Grasshopper components like this needs to provide a name, needs to provide a nickname, needs to provide a description, needs to provide a category, and needs to provide a subcategory. Subcategory, all right? And then whoever does that, what this component is going to do is going to say, you know what? I'm not going to do anything with this. The only thing that I'm going to do is I'm going to pass all this information up using this base call to the parent Grasshopper component. So I'm going to say, this is going to go up, nickname, description, category, and subcategory. Whoop, subcategory. All right. Okay, beautiful. And then after this, what I'm going to do is I'm going to rewrite this component here. Remember the Grasshopper post request component. And now the beautiful thing is that instead of inheriting from Grasshopper component, I'm going to inherit from Grasshopper component post sync, so that I get this additional bonus function as part of the package. So let me rewrite this grasshopper underscore component, but you can see that the post async is not showing up. That is because we're not incorporating, because we created this in templates. This is because this is in a different namespace. So I need to go here and say using brain.templates. And now that we have that, this grasshopper, grasshopper underscore component post async. All right, beautiful. So we create with the constructor, we pass the names that we want upwards, correct? And then we do, and then what we're going to do here is, remember all this stuff, all this, we don't need this anymore, because since we are in a template that already contains, as you can see here, a post function, what we can do is we can come here and say, I'm going to create a variable called response, and the response is going to be the result of using the post function with a URL, and I have the URL here from the inputs, the body, the content type, the authorization token, and the timeout. All right? And then I'm going to output that. What I've managed to do with this is that, let's see if this works. So I'm going to go now to post request synchronous. So if I run this code, you can see that this component, the HTTP post request, is the same as we used to have, but internally is now using the new templates. But if I turn this on, you can see that it takes a couple seconds, still blocking, but it does give me a response. Right, fantastic. So that what that means is that this is working, and that the Grasshopper HTTP post request component is now using the template that I created to automate all possible synchronous post components that I may want to develop in the future. Okay, beautiful. Hooray! Whew, that was quite a lot. Now, let's take a look at how could we do the exact same thing, but for the asynchronous version, which is arguably the one that we will definitely implement more often, and the one that has the most stuff that we will want to reuse and recycle. Let's take a look at that. Let's start by thinking, what is it that we want to reuse from the asynchronous post request component? So any component that will do an asynchronous post request is going to need these three properties. So a global response property in the class, a flag of whether if it should expire or not, and some kind of description of the state of the request, right? So that will be something that we will need to reuse and implement as part of the class. Then the solve instant method does have a lot of code that will be shared across different instances. So we will need to address that. And then we will have both the asynchronous post request, which we will probably copy and paste as it is, right? And then the idea that we will override the expired downstream objects, because this needs to have a specific way of being of behaving that is particular to asynchronous post request components. So then let's try to work with that. So I'm going to create a new class again, and the class is going to be called this. It's going to be Grasshopper Component, and this one is going to be post asynchronous. Okay, so we're going to do that. And then, as we did before, what I'm going to do is I'm going to mark this as a public abstract class that is going to inherit from Grasshopper Component. Where is Grasshopper Component? Grasshopper Component is right here. Okay. I'm going to, just like we did with the post, I'm going to add a constructor that basically takes whatever names and nicknames and blah, 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 and passes them upwards one level to the Grasshopper component using the base method, all right? Then the easy part, I'm going to copy the post async part of the component. So that was here. So I'm going to go all the way down here, private asynchronous, blah, blah, blah. So I'm going to copy this, correct. And then I'm going to do this. All right. And then I'm going to make sure that this is flag protected so that it can be used by children. And I'm just going to rename this post async because I kind of like this a little better. All right. So this is not working right now. Actually, I still have Rhino going on. Anyway, and this is not working because as you can see, let me post this here. As you can see, response, current state, and should expire, which are properties that we need as part of the component, are not available in this implementation. So what we need to do is I need to go here and say this are going to be part of the template that I'm going to be using. All right. And instead of private, I need to make sure that I flag them as protected so that it can be used by children. Okay. Now request state is, I am getting an error in this is less accessible than the field, blah, blah, blah components. Let me take a look at what is going on here. Yes, the problem is that I flagged request state as protected, but it turns out that the enumerator itself is less accessible than protected. So I'm just going to make this public, and then this should fix the problem. Okay, fantastic. And then what else do we need to do? We need to bring in, if you remember, we need to bring in the override for the expired downstream objects. So I'm going to copy and paste this, and I'm going to bring it over here. And now we have this overwritten, okay? And that should do the trick. So if I now go back to the Grasshopper component asynchronous, I should be able to use this Grasshopper component dot asynchronous. I probably need to bring in using brain.templates, and I probably need to use the Grasshopper component post asynchronous. All right. When I do this, this is going to be redundant because it's already part of the abstract class, right? I'm going to delete this. Oh no, I mean the get component. Oh, I'm sorry. Not here. Not here. So Grasshopper. Oh boy, I think I broke something here. Oh, what did I break? Yes. Okay, and then post asynchronous. This one is request asynchronous component. Exactly. So this one, I'm going to be using brain.templates. All right. And then here, this is going to be Grasshopper component. And so Grasshopper component post asynchronous. All right. So this is now redundant. I'm going to get rid of it. And then all the way down here, I'm going to get rid of this override. I don't need it anymore. It's part of the base component. This asynchronous post, I've already made a copy of that with a different name. And this is called now post asynchronous. All right. Fantastic. And everything else should probably remain the same. Let's see if this works. So I'm going to, oh, I'm using this twice. Okay, so I'm going to run this, okay, see if it works. Let's take a look. Ta-na-na-na-na-na. Ta-na-na-na-na. Sound effects. Okay, and it's showing up on my other screen. So if you remember, HTTP post request asynchronous is the one that we just overdid, and it's using now the underline template. So I'm going to do true, requesting, and then it takes some time, complete. Once upon a time, there was a beautiful princess who lived in blah, blah, blah. Okay? Okay, so it looks like it works, which is great and kind of surprising that it works at the first time. Now, one thing that I would like to highlight is You're probably thinking, well, turns out that the solve instance does have a lot of redundant code. So I'm probably going to have to be copy pasting this should expire, handling the request states, etc., etc. And then this whole like, if this is not working, expire the solution. If this doesn't work, expire the solution. So is there any way we could reuse this code and not have to copy paste the entire thing? And you're right. That is something that with a little bit more thinking and a little bit more design, maybe we can find a leaner way of having Solve Instance do some of these things automatically for us. But for the time being, I want to focus on getting the job done and the simpler version of this asynchronous component. But perhaps what I'm going to do is I'm going to let folks here in the community, together with me, think and prototype a way of how we could make this leaner. And perhaps what I can do is I can record another video once we find a cleaner version that doesn't require us to copy paste all this code that is redundant inside of Solve instance. Okay, so I'm going to leave that as an exercise, homework for us, for the community, etc., etc. And before we finish this video, I want to show you how we could do this, the same for get synchronous and asynchronous. Let's take a look at that. So I have implemented this offline during my live stream. So if you want to see how I did this, a card to the live stream might be popping up in the corner. All right. And what I've done is I have implemented a HTTP GET request that is synchronous. So if you look at the code now, this is the new component. And then if I turn this on, you can see that it did block for a little bit, right? And it gives me a request for this random website. Okay. Now, what's interesting is that instead of creating a new template for Grasshopper component, get asynchronous, Grasshopper request, post get synchronous, etc., what I found is that basically in the synchronous template, we did have a function that was a post request. But what I could do is like, for no reason could I not just add the same get request function on the same template. And what was interesting as well is that in the case of getting, in the asynchronous template, I had all these placeholder properties and all the code for handling an asynchronous post request and the expiration of the downstream object. But all of that code is very, very similar also for an asynchronous GET request. So if I go down here and you see that I implemented GET asynchronous, which is also using these properties, and it also requires the expiration of downstream objects. So what's interesting is that as I was developing this, I kind of realized that instead of creating one template for post asynchronous, another template for get asynchronous, another template for post synchronous, etc., what I could basically do is I could create one template for all synchronous requests of any type, and the same template for all asynchronous requests of any type. So what I'm going to do now is I'm going to basically refactor this. I just pressed Ctrl R twice. And what this does is that it changes the name on this class and anything that uses this class. So what I'm going to do now is I'm going to rename this to a more generic HTTP asynchronous request that includes both functions for post asynchronous and functions for get asynchronous, the same functionality. And here, I'm going to also refactor this, change all the names in my code base to something that is using HTTP synchronous. So this template is now generic for any HTTP synchronous request, and the file names do not get automatically refactored. So I'm going to rename the file as well, right? And then with this, I can use this template for any synchronous request, and I can use now this other template for any asynchronous request, no matter if they are get or post, which makes the code cleaner, more reusable, etc., etc. It's like a leaner and better, right? And then what I've done is I've already taken all the components and I have replaced them with their templated versions that will be very useful for me moving forward in the project. And once we start systematically implementing many components that use HTTP post, get, synchronous, asynchronous, etc., etc. All right, so we have a really neat code base now to start cranking out components. Okay, beautiful. I think with that, that's what I wanted to leave it today as a video for optimizing and writing a bit of a cleaner code base for our plugin. All right, fantastic. If you liked this video and you thought it was interesting for you, maybe show some gratitude, liking the video, subscribing to the channel, and all those things. Or if you don't, that's also fine. See you in the next video. Bye bye. Thank you.